Assalamualaikum warahmatullahi wabarakatuh. My name is Fali Pratama. I am from the 9 group, and the group member is me, Fali Pratama, Dafa Ajani, Rehan Tabi Ananda, and Zidan Fedi. In group 9, we discuss about the game procedure chart. So, the first, what is the game process chart? The game process chart is a chart that helps determine the most economical number of machine one worker can operate. However, several processes that facility are of such huge huge magnitude that instead of one worker operating several machines, the several workers are needed to operate one machine effectively. So, the GAN process chart show to extract the relationship between the idle and the operating cycle of the machine, and the idle and the operating times per cycle of the worker who serve the machine. This chart reveals that possibility for improvement by reduce both operator time and idle machine time. And we will see the illustration of the gang process chart from for a process is in which a large number of idle work exhausts or hour exists up to 18 18.4 hour per 8 hour shift. The chart also show that the company is employing two more operators than are needed. By relocating some of the control of the process, the company was able to reassign the element of the work so that 4 rather than 6. So worker could be effectively operate the extract press. A better operation of the same process is shown in the gown process in the picture 2.16. And saving 16 hours per shift was easily developed through the use of this chart. This is the chart 2.15 and 2.16. And when when the time to use this chart, the GAN process chart is used when several workers operate one machine, and the chart helps to exploring the possibility of reduction the redux both of operator time and idle machine time, because it's shown how many workers in one machine, identify idle time for each, rearrange tasks between workers to reduce the idle time. And the basic use or the purpose is to analyze the activity of the group and then compose the group so as to reduce the minimum wait time and delay and time delays and determine the interaction between worker to achieve efficiently and coordinate. So, how to use it? To use gang process chart, are need all you need is just 4 steps for analyzing a gang process chart. The first step is that 6 questions of what, who, where, when, how, and why are asked for the entire process. Second, each operation and inspection is analyzed by analyzing and the same 6 questions. Third, the remaining transportation and storage are studied. Four, or the last step is how the question should be applied in the new way after refinement have been complete under the 1, 2, and 3 step. This is the symbol or the draw and explanation, the tool or the chart with the case study. This is the symbol. White for the combination word, gray for idle time, and black is show the word not depend on each other. The study case number 1. It takes an operator 1 minute to serve machine and 0.1 minute to walk to the next machine. Each machine runs automatically for 3 minutes. The operator earns $10 per hour and the machine costs $20 per hour to run. How many machines can operator serve? And the optimum number of the machine that the operator can service is. So as you can see, the n is the number of the how much machine that the operator can take, with I is service time of the operator times with the machine run by itself per the operator service time times the walk or the idle times. So the result is 3.6. That number being fractional, that leaves two choice. The operator can be a size 3 machine. This is the option 1. In this case, the operator will be idle some portion of the time, or the operator can be a size the formation assessment for formation is the option 2. In this case, the machine will be idle some portion of the time. So the best choice may be based on the economic of the situation. That is, the lowest cost per unit in the option 1 is expect production cost from its products cost from the equation number 1 is divided by 60, so has to convert our 2 minutes. With the formula, as you can see, the tech 3 in I plus I is the service worker plus the automatic machine do times the K1 plus N1 times by K2 per N1. So it get one it costs 1.556 per unit. An alternative approach is to calculate the production rate R per hours, with R same with 60 is 1 hour same with 60 minutes per E. E is the surface of worker plus M is the automatically machine work same with times by N1. So the production rate is based on the machine being the limiting factor, or in this case is the worker is the idle at the time, and the machine production on the 1 unit per machine per 4 minute total cycle, 1 minute service time and 3 minutes of machine time. With the 3 machine running at 60 minutes per hour, the production rate is 45 minutes per hour. The expected cost is then the cost of the labor and the machine divided by the production rate. So the expected cost is the cost of the labor and the machine divided by the product rate. So it get 1.556 per unit dollar per unit. The option 2 is to expect production cost from the equation 2 is 1 plus W plus K1 divides K1 plus N2 plus K2 times K2 same with 1 plus 0.1 kurung times by 10 plus 4 times 20 per 60. So it's get 1.65 per dollar per unit. In the alternative approach, the production rate is based on the worker being the limit factor, or the machine are idle at the time. Since the worker can produce 1 unit per 1.1 minute cycle or 10 minute service time and 0.1 minute work time, the product's rate or error per hours for the alternative approach is 54.54 unit per hour. The expecting cost is then the cost of the labor and machines divided by the product rate. So it get 1.65 unit per 65 dollar per unit. Based on the lowest cost, the setup with the three machine is the best. However, if there is market demand at the good sell price, profit can be maximus using a four machine setup. Also that this is the example with a work time of 0.1 minutes. Production decreased from the ideal of 60 unit per minute, or the not is effect of the reduction time, a reduction loading or unloading time for 1 minute to 0.9 minutes. A relatively small amount of the option number of the machine that operate can serve now. So n is 3.9. Although the number is different, but it's very close to 4. So the realistic amount of the operator is assignment 3 machine in option 1. The operator will be idle a greater portion of the time, increase from 0.7 to 0.9 minutes or almost 25% at a time. That expect production cost from equation 2 is where 19 need to cover hours 2 minutes. So the tech 3 is 1.517 dollar per unit. So the alternative approach yield in the product rate is the R is 46.15 hour unit per hour. So that's all for today. Sorry for the mistake is assalamualaikum warahmatullahi wabarakatuh. Thank you.